think it will take a while for tea break, so we'll start. So in this particular lecture, we'll discuss what all data we require to set up a SWAT model and how to prepare that data, essentially how to download the data. So we'll start with our catchment data. So in SWAT model, the first step is watershed delineation, and to delineate the watershed, we have a digital elevation or elevation based delineation. So for that, the first input that we require is a digital elevation model, and then we have land use and soil, which is another basic input for that goes into the SWAT model, because I think many of you will be aware SWAT will compute its all the watershed level processes at HRU level, which are hydrological response units, which are a combination of land use, soil and slope. Slope comes from elevation, that is from DEM, and LULC and soil will be the other two components that will make up for the HRU. So to obtain the HRU, we need these three basic inputs, and then to simulate the processes such as runoff or evapotranspiration, we need climate data, which is essentially rainfall, temperature, soil, solar radiation, relative humidity, wind speed, out of which generally we will have rainfall and temperature readily available, and the other data will be taken from the SWAT database. Apart from that, to set up a fundamental model, we will generally calibrate it with the discharge or the observed stream flow. So that is what is one output we will calibrate our model with because of its availability. Also because stream flow represents the kind of average whatever is happening in your watershed, we can get an idea with the stream flow. So since it is readily available and it is a good representation of what is happening in the watershed, observed discharge is another data that we need for the model calibration. And then other than that, to get a basic idea about whatever basin we are working in, what are the different features of let us say how many gauge stations are there, what is the basic hydrology and other information, we will use the basin reports. And shapefile is also required to have a rough estimate of the boundary of your basin. Although watershed delineation will give us the shapefile of our basin, but still to have a rough idea, because CWC has divided the entire India into 24 major basins. So those basin shapefile, nothing but a vector data or the boundary of your catchment, is what is required to have an idea about how your basin looks like. Or sometimes when we download the DEM, we will download it for a larger area, so to mask it out we will use that shapefile. So DEM, as we know, it is nothing but a raster or an image which contains information about the elevation. So raster is an image which has a pixel value, and that pixel value in case of DEM is elevation. So each pixel represents the elevation of that particular location. And it is useful in SWAT because this DEM will be helpful in telling us the catchment properties such as the slope and the length of the slope and the watershed area. Everything will be computed based on DEM. So as you know that based on the elevation difference in SWAT, we will compute the flow direction and the flow accumulation using the steepest direction in which your flow is going. So the first step is the slope computation that will come from DEM. And apart from that, the drainage network. Maybe tomorrow you will see that based on the threshold that we give to initiate the stream network, your entire processes will be depending on that threshold. So in a way, it also controls our hydrological variables. So in fact, a study by Chaube sir was conducted long back on to see that how the resolution of the DEM affects the processes. and it was found that in general for stream flow it doesn't affect the resolution of the dam, doesn't affect the runoff, but there are processes such as sediment computation, sediment yield, that are affected by the resolution of the dam. So here are the four common sources that you might have come across for dam. One is the SRTM 30 meter dam. The second one is Aster dam 30 meter. All are openly available and globally available. So, and the third one is Elos dam, and the fourth one is Cartoset dam by Bhuvan. So commonly SRTM dam is used. So SRTM and Aster, they both come from NASA, but the only difference is in the extent of the location that they cover. So Aster covers a little bit more area as compared to SRTM in terms of the global extent that is covered. So I will just quickly show you how to download a tile for a location using SRTM. So essentially you need to create a USGS Earth Explorer account for it. Using your email ID you can create, and once you create that, it will take you to this kind of a page. Now already you will be knowing that on what basin you will work on. So roughly you navigate here and take it to your location. Let us say we want to delineate for an Indian basin which is located somewhere near Warangal. So here you can use the map and you can create a polygon. So just click on that and try to create a polygon. Rough idea you will have that this is the area which will cover your study area, and then like this it will show you the coordinates of your polygon. Then you can go to the data sets, and here you have a number of data sets which are available by USGS Earth Explorer. You can click on digital elevation, and there you will have the SRTM 30 meter dam, 1 arc second global, that is nothing but 30 meter dam. And then it will show you all the tiles that are, all the dam tiles that are covered by your study area. So here we can see that only 2 dam tiles are covering this smaller area. One is this and the other one is this. So like this you can download. Once you are logged in, it will allow you to download. In the same way you can download Aster dam. This is also available from Earth Data Search, and you just need to create your account, and here you can type for Aster dam. Still there is nothing like which is better than the other one. Mostly they perform similar, and you can also use literature to take support of which particular dam you are taking. So, rightly pointed out by Sir, it also depends on your purpose, and you can always cross check with the data that you have in the form of topo sheets. So, like this, you can also download Aster Dem. Just need to type Aster, and it will give you all the products that have used Aster instrument. And Aster Global Digital Elevation Model version 3 is the latest one. So you can download the tiles, and later you can process them to get the digital elevation for your study area. Similarly, we can download Cartoset Dem from Bhuvan website. All you need to do is log in, and then sorry, this is not the interface for Dem, but yeah, you can just click on this link and it will take you to the page where you can select the region and download the Dem tiles. So here you can select land and terrain related products, and it will give you all the available versions of Cartoset Dem. And this is how India is divided into different grids, and you can select your grid by using interactive drawing. Then just start, select, suppose this is the tile I want to select. And like this you will have your dem data in all the different versions which you can download. This is 10 meter, and the rest of them are for 30 meters. And Elos dem is also a fine resolution dem which is available at 12.5 meters resolution. Another source to download all this data is using Google Earth Engine, which I think some of you will be aware of. So all these products, not all but some, for example SRTM DEM and NASA DEM, they are available at Google Earth Engine datasets. So just you need to write one command to export that data, and you can give your study area shapefile, and it will directly give you the DEM for your entire study area, and you will avoid the steps of merging or pre-processing of the DEM, clipping of the DEM. Directly you can download, but you need to check that whether you are exporting the same data set which you want, because there are n number of data sets available for DEM itself. Next up we have LULC. LULC essentially tells us about the land use of a particular area. So for land use we have ISRI data 10 meters available. From NRSC Bhuvan we have open source 56 meter data available. And from MODIS, which is a global product, we have 500 meters resolution land use cover. So again it depends on what is your purpose, and also whether your study is large scale or small scale. So if you want to really include the processes which represent vegetation, or any other such fine resolution data is required, then you have to go for a sub level of land use. So to the right you can see this is the NRSC land use for a sub basin of Godavari, and here these are the classes that are available in this land use. So if you want to further go down what is there in the Kharif, whether what crops are available, then this land use is not the right land use for you. You have to further classify it. Even the ISRI 10 meter resolution will give you only the agricultural land. So it depends on what is the purpose of your modeling. If you are really not interested on the intermediate processes, you can go for any of these. Or else you have to reclassify them by using some ground data. The next product is soil. Again, for soil there are different sources, but one commonly used is FAO soil. So this, all the three I'll just show you. This land cover ISRI that is available from ISRI is available from 2017 onwards. So again, if your time period is back to 1980s or 90s, you cannot really use this. You have to either rely on, I think Bhuvan is also available from 2005 onwards. So either you have to classify the satellite images, maybe Landsat, because Again, Sentinel is not available after, I mean, before 2015 or 16. Or else you have the option of using coarse resolution DEM. For example, we have 100-meter resolution land use land cover, which is available at 1985, 95 and 2005. So many of the studies that are assessing the impact of land use, they are using those land cover maps. So the downloading part is very simple. You just need to go to this ISRI website, and here you have the option of downloading the data. It will take you to a page where the entire world is divided into different grids, and just click on that. So I'll just click on any of these and it will tell me, it will ask which year I want to download, and the LULC will be downloaded as a raster file with all with this particular year data. And what are the classes that are available, that also you can know from this website. So essentially ISRI has 9 LULC classes. So these are the classes that are there. Then for Bhuvan land use, we have 56-meter resolution data that is available to public openly. But I think we need to put a request and then they will send the data by email. So this is the land use by Bhuvan, and then maybe we can just put a request for whichever state or number of states we want, and they will provide. So again, this data set is only available from 5 to 2023, but it is only interested to those people who are working on how the changes are happening in the land use over time. For basic SWAT model, you can use a single year LULC for preferably for the latest years, so that you can account for most of the processes. And then for FAO soil, you can download the shapefile. So this is the digital map, soil map of the world with coarser scale. So you can just directly download the shapefile in the ISRI format and it will give you the data. So once your land use, soil and digital elevation map or digital elevation rasters are ready, so basically soil and DEM and LULC will be in the raster format that will be available, and soil will be the vector. So you can process them to your study area and they are ready to use. Other data that we need is climate data, which is rainfall and temperature. These data are available in from the IMD portal. Rainfall is available from 1901 to I think 2023 or 24, and temperature is available from 1951. These data are available in the NetCDF format, which we can extract to our study area. So entire India is divided into a set of grid points. So there are particular latitude and longitude for which rainfall is available. We can extract the rainfall for our study area period. So we'll show you later that how we can extract it, but this is how the data is arranged, and you can download easily all these NetCDF files and extract it for your study area. And this data is available at 0.25 by 0.25 degree, so essentially 27 kilometers resolution, and temperature is available at 1 degree resolution. Then talking about the observed discharge, so in India we have the discharge stations, the stream gauge discharge stations for every basin. Number of stations are available, and again it depends, but generally we will use at least 20 to 25 years of data for hydrological modeling purposes, and it is available from WRIS, which many times don't work, but I will try. So this website is not working, but I think they have updated their portal. So here, but it is, I think they are still working on it. So let's say we want river discharge and then we want it with the hydrological boundaries, not the administrative boundary. And let us say I select Brahmani and Baitarni as the basin and the agency, and then I can select the tributary. So beforehand, if I know that where is my outlet located, I will put the river, and the agency will be CWC. And then I can put the start and end date. It will, so I think they are still working. It is available in this portal from 2014, but there are other sources to download. But essentially WRIS is the main platform from where we can download the observed discharge. Then basin reports, these are also important. As I mentioned, it will give you an idea about how many stations are there, where are the stations located, and the same kind of information will be available in water yearbook. So you will know that at that particular station whether data is available or not, and from which year it is available, what is the lat long of your outlet. Because in SWAT, while applying for watershed delineation, you need to give the outlet of your basin. So that outlet lat long you can know from water yearbook. Then next is for the shapefile. As I told that CWC has divided the India into major basins and sub-basins. We'll just go through this platform after a short tea break. So tea is ready. I think we can take a break. Okay, so as I was saying that apart from the time series data of discharge, sometimes we need some other information about the outlet station, so that you can get from the water yearbook. And for, let us say for Godavari basin, we have the latest by 2017 and 18. So it is an edition, uh, yearly edition, and it is basin wise. So what they will give is the annual runoff at all the gauge stations that are present in your basin. So let us see for Godavari. Suppose before itself I will know that I am going to work in, let us say, Indravati basin. So I will just search Indravati, and then it will show that what all stations are present, gauge stations are present at Indravati basin. So let us say Patagudam is one of the main outlet at Indravati basin. So I need to know the lat long of Patagudam. So this is the terminal station. So we can see what is the drainage area of this particular station. So this is at the terminal. So entire drainage area of Patagudam should be roughly around 40,000 square kilometer. And in SWAT, suppose when you delineate and you get some higher area, some 60,000 or some absurd value, then you will have some reference to cross check. And then you can also get the correct latitude and longitude, because it is published by CWC, so at least we can have some confidence in these values. Also we will know, because sometimes the data is not available and we have to request, so we will know that the data at Patagudam station is available from 1964 for discharge, and this for sediment. In case you are going for sediment yield calibration also, then this is the place where you can get from what time to what time your data is available. And in case some people go for multi-site calibration, then let us say we have 10 outlets. So which is the outlet, or which are the 2-3 outlets where we have the data, this information we can get it from here. And annual runoff is also available. So this water year report is available at this particular link for all the major 22 basins. Next we have the CWC released shape files for all the 22 basins. I think earlier it was not available directly from CWC, but now they have updated their portal. So this is that portal for geospatial data. You can directly go to WRIS website and the pop-up will come for geospatial data. Here you can see all the different data that are available. For shapefile, it is a hydrological layer. So we will click on this and it will give me the basins as well as the subbasins. So again, this subbasin data, I think it was not available before the shapefiles by CWC. So this is available. It is also a good way to cross check or to download your DEM tile or to cross check whether your watershed that has come out after delineation is kind of matching with this or not. And then you have multiple data sets depending on your requirement, reservoirs, dam shape files, so that sometimes we are also interested in understanding how the reservoir will create an impact on our hydrological response. So where to place the reservoir, the shapefile will give you an idea about it. And then we also have administrative level data, so up to village level data openly available from this platform. So I think you can just explore this platform. And one important data that is available now is the command area data. So earlier we used to digitize the command area. So suppose someone is interested in land use classification and they want to know that what is the irrigated area in that region. So we had to digitize this from the WRIS website in QGIS or ArcGIS, but now that command area shapefiles are available to download. So here there is a option water resources project, in that we can download the command area. So project command area, so it will have in the attribute table, you can check. I have already downloaded it, so I will show you. In the attribute table you will know this is the command area falling under major irrigation project or medium or minor, what is the area of that, in which state it lies, and all the attributes related to that particular shapefile. So again, it is an important data set that is now available. Apart from it, sometimes we are not able to obtain time series data, and we may have to rely, maybe someone else has downloaded it, maybe we can take from them, but there are some papers which have this database. So one of this latest released papers is this particular paper by Nikunj, a research scholar from IIT Roorkee, and this dataset was available for US watersheds. Camel's India dataset. Basically, this dataset will have all the catchment attributes. So you can see this is the paper. So for the peninsular India, the peninsular basins that are there in the South India, there are 472 gauge stations. Again, this is a before this paper there was one other paper by Gopi, another I think research scholar, who has divided the entire Indian gauge stations into three categories. One is where we do not have adequate data, another one where we have some data but it is not reliable, and another category where we have adequate and reliable data. So out of this, 472 gauge stations were found that were having the data. So this particular paper gives us 41 years of data, again acquired from different sources that we download like WRIS or rainfall from IMD. You can just go through this paper. I think it will be useful for those of you who are going to download that data. So instead of downloading just from different sources, you can just take it from this paper. as it has mentioned the source also. For them, generally we take rainfall and temperature many a times as the independent variables. Now we can take some of the catchment properties also as the independent variables, because this data is a long term 41 years data. So I think this is also one useful source. So it is taking time to load, but anyways, they have released a document supporting that what all data are there and what are their sources. Okay, so next, as I mentioned that for rainfall data extraction, so rainfall is arranged or the temperature is arranged from IMD portal in a net CDF format. So it is nothing but a data format where the data is arranged like this array or a matrix, where two dimensions are latitude and longitude and the third dimension is with the time. So you can think of this orange square matrix as one time step. Let us say today 3rd December 2024 you have the rainfall, and the next one you have at maybe 4th or 5th, because we have daily time series data, and all these locations are nothing but your latitude or longitude where you have the rainfall value. So once you download the data, you will have these three attributes. Suppose your study area lies in some let's say India is divided into 400 or 500 grid points, so you can extract the grids which are falling into the study area and then extract the rainfall and temperature at those particular points. Sometimes the latitude and longitude which are available in the data are not matching with what you have. So in that case you can go for interpolation, maybe a linear interpolation you can do, and get the get the rainfall or the temperature value at your desired location. So this is essentially a simple step. All you need to do is see what all grid points are falling in the country, clip it with your study area shapefile, and for those points extract the rainfalls. If they are not available, because let us say rainfall is available at 0.25 and temperature is available at 0.1 degree. So the latitude of where you have the rainfall, you may not have temperature at that latitude. So in that case you have to do a interpolation so that you have the rainfall and temperature both at the same location. So this can be done by using any programming whichever you are comfortable with. So for tomorrow's session, the data will already be shared with you, but in case you have time and you want to just try it out, you can download one netcdf file and take up your study area and extract the data and see how it is coming up. Then next we will just see basic operations, which I think many of you will be aware of. So once we download the DEM tile or LULC raster or the soil shape file, how we import it, how we prepare this data to our study area so that we are ready to give to SWAT model is what we will just see in few steps. So, so this is QGIS basic interface. It is open source. I think many of you might be aware of. You can download any latest stable version. It is openly available, and this is where you can you have the toolbar, and this is where you have the processing toolbox. So whatever steps that you are going to perform, whatever processes that you are going to perform, you can just type it out, and if it is there in the QGIS, it will show you. This is where you can keep your data. So this gives you an access to your system files, and then this is the layer section, and where you whatever vector or raster data that you import will come here, and this is the interface. So let us say that I have my data here, and I can just keep that folder as the favorite so that I need not take it again and again. I can just add it as a favorite, so it should appear here. So let us say I have downloaded the dem tile and it is stored like this. So I will just load it, or there is an alternate, you can go to layers and then add layer, and then depending on what is your data, whether it is vector which is in the form of points, lines and polygon, or whether it is a raster, that is the geotiff file, you can add the raster layer and you can browse through the data folder that you have and you can load it. So it depends on, it is like, finally you have to load the data to this interface. So let us say I have 4 tiles. These are the 4 dem tiles that I have downloaded from SRTM. I have just shown that how we can download. And then roughly I want to set up a SWAT model in one of the watersheds in Krishna basin, lower Krishna. So let me load my region of interest also. So this is the shapefile of one of the watersheds. As you can see that it is falling across the 4 different dem tiles. So I do not have a single dem tile which covers my study area. So the first step that we have to do is we need to merge the dem tiles. So I will take these 4 tiles and I will just type here merge. This is one option, or else you can go to raster, and here also you will get the same option merge. So you can load all your tiles and merge them. So now you can see a single tile which is merged. Now the second most step in SWAT is your DEM data or your LULC, everything has to come in single projection system. So you must be aware that to represent anything on earth we need to locate it, and that we do it in GIS with the help of a coordinate system. And we have two kinds of coordinate system. One is geographic coordinate system and the other one is projection or projected coordinate system. So GCS or the geographic coordinate system works in terms of latitude and longitude. So it is basically telling us where on earth anything is located in a way that it is on the globe. So it works in 3-dimensional way, but projection coordinate system is when you want to project it to a linear system or a 2D system. So whenever you have to do some computation like calculating slope, area, you need to take that in a linear measurement. So that way PCS is important. You need to always project your rasters or shapefiles in a projected coordinate system. And for GCS, generally we have different models for Earth. Spheroid are there, and there are so many models of how Earth looks like. So WGS 94 is one of the most common GCS system that we use. So in that system, all the places on Earth are kind of accurately represented. Although there are individual systems also, like Australian WGS is there, not WGS, like Australian data models are there. For North America it is there, but we use WGS because it is most accurately representing all the places of Earth roughly. And for PCS we use UTM. So UTM divides the entire earth into number of zones. So before we reproject our DEM to UTM zone, we need to know in which zone it lies. So for that we can download the UTM grid file and we can just overlay it to our DEM and find out to which zone our area belongs to. So this is what I am going to do. I will just overlay my UTM zone file. And then I will just label it to know to which zone it belongs to. So I will label it with zone. So you can see that 44 is the correct zone. So I think in India we have 42, 43, 44. I think entire India is covered in these zones. So within a zone, our representation of the earth in this particular zone will be accurate. If I give 43, some errors will come. I will misrepresent my information in projecting. So that is why we need to give the correct zone. Many a times our region is falling in two different zones or multiple zones. That time I think we can just see what is the majority of the area lying in which zone and then just reproject in that. So it is a simple process. Just go to properties, go to layer CRS and then set the coordinate reference system, and then you can search for 44N. So WGS UTM zone 44N, and then it will be reprojected. So now our DEM is reprojected. Like this we need to reproject our LULC as well as soil. So this is the basic step. And then about clipping. So let us say I got this merged tile and I have my region of interest also. So now I want to clip my DEM to this study area. We generally do not have to clip exactly to the boundary, because in that case we may do something wrong while delineation. So we generally keep a mask of, we keep some extra distance, some buffer of some kilometers, and then mask it out. Otherwise if you give the entire DEM for pre-processing, it will unnecessarily it will take more computational resources of your system. So to avoid that we'll just merge. But what I found is the better way to avoid this taking the tiles and then merging it is directly you take, if you are interested in SRTM, then better to take from Google Earth Engine. It will just directly give you. So you will type the clip option, clip the raster, because you are clipping DEM using a mask of your study area shapefile. So we'll give DEM as the input and we'll give the region of interest as the mask layer and run it. So you can see your DEM is clipped now. These are the background values which you can remove by assigning them to 0. So this is how you can clip. These are the three major steps that you will be following each time you set up the SWAT. You download the data. You need to download all the three datas, DEM, land use and soil, and then you need to check their projection system, and then you need to clip it sometimes to your boundary. And with respect to LULC, you need to make sure that you have the classes which are present in the SWAT database. So apart from that, there is only one thing, that is you have the gauge station many a times, because I showed you, now we have the gauge station shapefile also, but in case you have only lat long, then how do you import it in QGIS or ArcGIS and then make it as a shapefile? So let us say I have some lat long data, so I have rainfall grids. I will just show how to convert it into a shapefile. So we will add, whenever we have a CSV file, we will add it as a delimited text layer. Since we do not have a geometry and we want to assign a geometry to it, so this is the rainfall grids. It will be added as a point data, a vector data, where our x field will be the longitudes and a y field will be the latitude. And I also need to assign a CRS, coordinate reference system. So once I do that, it will be added as a point shapefile. Now easily all these shapefiles I can clip with this DEM to get only, I think, 4 to 5 points that are there in my falling in my study area, and then whatever rainfall data you have in the netcdf file, you just need to extract it for those 4 points. So this is how you will obtain it as a shapefile, and then you can export it and then just give it a name and your desired location. And then it will be now stored as a shape file. So I think these are the basic steps that you require to set up a SWAT model for the input data preparation. This is it, and if you have any doubts, you can ask. Okay, then I think we can close the session. Thank you. Tomorrow's session will start at 9:30, so you guys please be here in the Khurana hall at 9:30 tomorrow morning.